The primary measure of stealth or low observability is the radar cross-section (RCS) of the target. RCS reduction is chiefly important in stealth technology for aircraft, missiles, ships, and other military vehicles. With smaller RCS, aircraft can better evade radar detection, whether it be from land-based installations, guided weapons, or other vehicles. Reduced signature design also improves platforms' overall survivability through the improved effectiveness of its radar countermeasures. The RCS of a stealth aircraft is typically multiple orders of magnitude lower than a conventional plane and is often comparable to that of a small bird or large insect. So today, let's check out the top 5 combat aircraft with the lowest radar cross-section. At number 5 is the Sukhoi Su-57. The Su-57 has a radar cross-section of about 0.1 square meter. The Su-57's design emphasizes frontal stealth, with RCS reducing features most apparent in the forward hemisphere. The combined effect of airframe shape and radar-absorbing material of the production aircraft is estimated to have reduced the aircraft RCS to a value 30 times smaller than that of the Sukhoi Su-27. The airframe incorporates platform edge alignment to reduce its radar cross-section. The leading and trailing edges of the wings and control surfaces and the serrated edges of skin panels are carefully aligned at several specific angles in order to reduce the number of directions the radar waves can be reflected. Weapons are carried internally in weapon bays within the airframe, and antennas are recessed from the surface of the skin to preserve the aircraft's stealthy shape, while radar-absorbent material coatings absorb radar emissions and reduce the reflection back to the source. It is now the first aircraft in Russian Air Force service to use stealth technology. At number 4 is Lockheed Martin F-35 Lightning II. Stealth is a key aspect of the F-35's design, and radar cross-section is minimized through careful shaping of the airframe and the use of radar-absorbent material. Visible measures to reduce RCS include alignment of edges, serration of skin panels, and the masking of the engine face and turbine. According to the existing tradition, foreign publications estimate the F-35's RCS at 0.005 square meter. The RCS of the F-35 has been characterized as lower than a metal golf ball at certain frequencies and angles. The aircraft also has reduced infrared and visual signatures, as well as strict controls of radio frequency emitters to prevent their detection. Looking at the rear view of the F-35, an exactly aligned search radar can see some of the F-35's engine turbine, which is a good reflector. If the F-35 is cruising at a modest power setting, the turkey feathers of its tailpipe are nearly closed and the orifice is small, which will greatly reduce the RCS. Additionally, the tips of the tailpipe vanes are shaped to scatter radar, as is the rear fuselage structure and the interface with the tailpipe. The spray bars are arranged as curving blades that hide most of the turbine from line of sight. At number 3 on the list for the top 5 combat aircraft with the lowest radar cross-section is Lockheed F-17 Nighthawk. This is a retired American single-seat, twin-engine stealth surface attack aircraft. The Nighthawk has a radar cross-section of about 0.001 square meter. The radar-absorbent flat sheets covering the F-17A weighed almost 1 ton and were held in place by glue, with the gaps between the sheets filled with a kind of putty material called butter. An exhaust plume contributes a significant infrared signature. The Nighthawk reduces IR signature with a non-circular tailpipe to minimize the exhaust cross-section and maximize the mixing of hot exhaust with cool ambient air. The F-17 lacks afterburners because the hot exhaust would increase the infrared signature, and breaking the sound barrier would produce an obvious sonic boom, as well as surface heating of the aircraft's skin, which also increases the infrared footprint. At number 2 is the Northrop Grumman B-2 Spirit. The B-2's low observable or stealth characteristics enable the undetected penetration of sophisticated anti-aircraft defenses and to attack even heavily defended targets. The B-2's shape means there are very few leading edges for radar to reflect from, reducing its signature dramatically. This aircraft is further enhanced by the composite materials from which it is constructed and the coatings on its surface. The B-2's flat, narrow shape and black coloration helps it to fade into the night. Even in the daytime, it is hard to figure out which way the plane is going. Despite having a 172-foot wingspan, the B-2's radar cross-section is 0.0001 square meter. The B-2's thermal signature is kept to the bare minimum, making it harder for thermal sensors to detect the bomber, as well as lowering the aircraft's acoustic footprint. Besides this, the B-2 is designed to contain its own radio signals, the electromagnetic energy generated by onboard electronics. The plane does emit radio energy when using its radar scanner or communicating with ground forces and other aircraft, but the radar signal is small and highly focused, making it less susceptible to detection. At the number 1 spot, we have the Lockheed Martin F-22 Raptor. The Raptor is so stealthy that it appears to be the size of a bumblebee when detected by radar, even though it is more than 62 feet long and has a wingspan of 44.5 feet. The F-22 Raptor's frontal aspect radar cross-section is assumed to be 0.0001 square meter, and the overall aspect radar cross-section is assumed to be 0.00016 square meter. Many of the surface shapes of the Raptor are curves with changing radii, and these curves scatter radar beams in all directions instead of back to the radar source. The sawtooth edges on cockpit edges, landing gear doors, and other openings also break up the radar. The edges of the main wing and rear wing line up exactly, making them appear much smaller on radar. The Raptor has 2 large vertical fins, and these vertical fins are angled like the body to deflect radar. The fins also conceal internal antennas that help maintain the invisibility of the aircraft. Unlike current fighters, it can carry missiles inside the fuselage, whereas other aircraft can only carry missiles under the wings, where they can reflect radar waves and make the plane much more visible. The idea behind all this technology is to reduce the enemy's ability to find, track, and target the F-22. And that's it from The Buzz for today. Thank you guys for viewing in. Bye-bye.